Hey, I'm Abhay.
I'm Amandeep.
And I'm Verena, and we will be talking about provenance in forensics. As scary or foreign as this may sound, we will do our best to explain these concepts to you in a way that makes sense and hopefully make this topic easier to understand.
The very first question that comes to mind is what is provenance? So, provenance is the place of origin or earliest known history of something. In many fields, including art, science, and computing, provenance is considered as a first class data of importance for tracing an object to its origin. Provenance is defined by a set of different properties about the process, time, and input and manipulated data. Provenance is used to answer a few basic questions such as when the object was created, the purpose of creation, and where the object originated from. Example, the creator of the object.
When a document is stored in cloud, provenance is important for data forensics to provide digital evidence for post-investigation. Provenance information has a wide range of critical application areas. For example, scientific data processing needs to be keep track of data ownership and processing workflow to ensure the trust assigned to the output data.
Simply stated, cloud computing is exactly what it sounds like computing on a cloud. Computing means anything you create on a computer. Pictures, documents, algorithms, and people's contact information are all examples of information you can use on a computer to save or run. The problem is that you can only use these objects on your computer. If you send an object through email or a thumb drive to any computer, this creates a copy of the object, but it's not the object itself. For example, if I shared these slides with you over email and then changed them, you would not have this change. You would have an old copy of my presentation. The idea of a cloud enables more than one computer to have access to the same object and be able to manipulate it in different ways, meaning I could provide a way for you to see live updates on my presentation. Of course, cloud computing is not actually this simple. It's not even a cloud. As you can see from the picture, there are three layers to having a cloud. A physical layer exists in rooms and rooms of servers and storage devices and networks. All of these interconnect to function as the physical layer of a cloud. The virtual layer connects the physical layer to the software of the cloud. This allows and sets the rules for how the user interacts with the physical layer. The application layer is for the user to interact with the cloud in ease. Having this base knowledge allows us to understand why provenance would be needed for cloud computing.
Talking about why provenance is needed in cloud computing, the answer to this question is introducing the provenance data into cloud infrastructure would result in the following advantages. The first one being trust, reliability, and data quality, because the final data output can be verified based on the source data and transformation applied. Then comes resource utilization. In cloud, provenance data can be used to utilize the existing running resources by allocating a copy of running resource. This will be achieved by comparing a new request to the already running resources, and this information is available in provenance data. The third one is reduced cost and energy consumption. Provenance data results in a cost and energy efficiency by using patterns to forecast a future request and by utilizing existing running resources. And finally, fault detection. Provenance data can pinpoint the exact time, service, method, and related data in case of a fault. It is also important to note that in cloud computing, you need provenance for all three layers of the cloud so that if there is a hack, a cyber forensic specialist can tell where it occurred. Since the cloud has so many working parts, it is hard to debug what goes wrong in the cloud, meaning we need to create logs for every single thing that goes on in the cloud.
Anyone looking for the origin or permutation to an object needs provenance in cloud computing. In the context of cyber forensics especially, two types of people need provenance in cloud computing. If a cybercrime takes place, cyber forensic specialists need to know what exactly happened to the object in question. Having a detailed account of what happened will help the specialist catch the things that seem out of place or unordinary to the document. Believe it or not, hackers also need provenance in cloud computing. Since provenance of an object will contain information about the object, it is essential to the hacker to have this information. This raises questions about the integrity of provenance that we will address later in the video. When a document is being created, the data owner can specify a fine-grained access control policy for the documents stored remotely in the cloud servers. Low computation and communication overhead at the data owner or user side. In cloud computing, the computational ability is not required to be high, except for the cloud server. Thus, a Provenance system with low computation for data owners and users is preferred in cloud computing. When there is a user to be revoked, the data owner has to update by recomputing all the broadcasts linked with the revoked user. Thus, such a naive approach is not practical, especially in cloud computing.
Along with a lot of advantages, there are some challenges related to provenance in cloud computing. We are going to discuss a few of them in this video. The first one is domain, platform, and application independence, which refers to how the provenance system works with different domains, that is, scientific, business, and database domain, platforms, and applications. Next is computation overhead, that is, how much extra computer space is required for provenance to work. Then there is storage overhead, which is how and where is the provenance data stored. It depends on the type, that is, the copy of original data or a link reference to original data, and the storage unit, which can be server or a file system. Another one is usability, which determines the ease of use of provenance system from a user and cloud resources provider perspective. How to activate, deactivate, and embed a provenance system into existing cloud infrastructure and services. Example, is it completely independent or modification is required on a cloud service layer? The last one is automaticity, which states that with huge amount of data and process computation within cloud, collecting and storing provenance data should be automatic and consistent.
Logging as a service is simply taking all these logs a cloud creates from its different layers and completes them all for one object. There are multiple loggers that we can choose to implement, but you chose this one for its simplicity and ability to effectively detect and minimize threats. A common principle we have to agree on is that in order to have provenance, you have to be authenticated. Logging says that if certain criterion are known to be true, then the object in the cloud is authenticated. Our first criteria is confidentiality. If we are sure that the contents of the document or object within a cloud is secure and confidential, then it is authenticated. If access is limited to the people that have access to the document, we can create a log of who can use it. This leads us to our second criteria, unforgettability. Being able to tell not only the people with access to the document, but the various permutations to an object helps have provenance. This also helps our third criteria, traceability. When I can tell who has access to my object and what mutations have occurred on the object, I should be able to tell who made a specific permutation to the object. The fourth criteria for authentication is anonymity from the cloud server. This means that only the people you give access to change your document should be able to change it. It is worth pointing out that this authentication is from the software layer of the cloud. Our fifth and final criteria is fine-grained access control. For our purposes, we will just define it as a way to authenticate who you are. Since multiple logs are created for each working layer of the cloud, Logging as a Service chooses to implement a checkpoint. At this checkpoint, Logging as a Service domain uses server agents, checking each log as it comes in and plugging it into authentication algorithms. If the log passes its authentication algorithm, meaning the log has not been tampered with, it joins all the other logs that belong to a specific object. These logs are kept in a secure server. When cyber forensic specialists need the provenance of an object, they can request a comprehensive record of this object's provenance. This is the visual representation of what is going on in Logging as a Service. Let's take advantage of this visual representation to explain some more precautions that the service takes to protect its authentication. The Visual Control Center manages the communication between the physical layer and the virtual layer. In each server, there is a virtual machine manager that communicates with the VCC, which communicates with the virtual layer. This also happens the other way around, having the virtual layer communicate with the VCC to communicate with the virtual layer, physical layer. This communication is meant to aid in maintaining what each layer expects of the other. This expectation of what each layer will provide is set by the application layer or user. This means that the VCC checks what is supposed to provide against what the user is requesting. If it is invalid or not part of the expectation, it will not provide it. In the event that it can provide for the certain action, it will create a log and send it to the management tool server. Another thing worth mentioning is the metadata relationship with the log records. A single metadata file is created for each layer based off the multiple logs. This means that even after all the authentication logging as the service provides, you can still check the logs of each layer to see if the metadata files line up with each of the logs for each layer. In cyber forensics, this often helps find discrepancies in the cloud that often catches cybercrime. Even though logging as a service provides all these benchmarks and barriers to being as secure a server as possible in order to protect provenance, it still fails in some respects. This is something that they are taking steps to address and find a solution for. The first thing it fails in is stealing authentication on the front-end side. If someone steals authentication on front-end side, such as login information, this person can access and manipulate objects they have access to and go undetected. Something to remedy this is providing two-factor authentication system. Another threat to this particular implementation is the manipulation of data at the log collection stage. When logs are collected through the VCC or any other sort, skilled programmers can manipulate these logs in the middle of the shipping progress to the system domain. That way, when a cyber forensic specialist looks into these logs, they seem normal and like nothing on the system is tampered with. In order to fix this, researchers are looking at making the shipping progress isolated so that no one can get to this data while it's being logged. The final threat we will talk about are imposter servers. To recap, the objects that you put on the clouds are saved in servers on the physical layer. If someone can get to the physical layer of the servers that host the cloud, they have access to all the information you save on the cloud. They have free reign to do anything they want with these objects. The first solution that has been implemented is the logging as a service agent in the physical layer that can detect if there are any imposter servers. Currently, researchers are also working on a cloud agent on the virtual layer. This will ensure that before the virtual layer communicates with the server, it will authenticate it. If the server does not pass the authentication algorithms, it will send a log to the logging as a service domain.
Here is a list of references that we used for making this video. We hope this video helps you understand the concept of provenance in cloud computing. Thank you for your time.